Hi everyone. After we set up a new project in the Xilinx ISE, now we should add our first design file. Right click, new source, choose the source type as schematic, name it one. Okay, now this is a schematic file here. Select the symbol channel. You can search any component. Use this symbol name filter. Here we add a AND gate, and 2. The number 2 here means it's a 2 input port AND gate. So put it here. Okay, then add a NOT and then OR gate, also 2 import, and NOR gate. The third step is we add wires to connect those gates together. Here you can see the button, left click, add wire. I think it's stuck. Okay. Notice that if there's a black box on the cross point, that means the 2 wires are connected. If there's no such black box on the cross point, that means the 2 wires are not connected. We finish the rest of connections. Then we add IO marker. The IO marker will clarify whether the port is an input port or an output port. Here, since our design is 2 input port and 4 output ports, so we add the IO marker here. Okay, step 5. We right click and rename the port. We will rename the port, making it more easier when we write it later in the test bench. And save the schematic file. Back to the design channel. Make sure right now we are still in the implementation selection instead of the simulation. Okay, right click, add source. I will add a new constraint file. The constraint file, okay, here will clarify and match the software port, like top bottom, to the hardware port, like K3A7. If you have a FPGA hardware board, you can see the K3A7, this kind of port name are printed on the board. Then you know our schematic files port, our circuit port top or bottom here will corresponding to the hardware case report A7 port. Okay. Then select the schematic file to the synthesize. It's done. Then we double click generate programming file. This step will generate a bitstream executable file, which can be later downloaded onto the FPGA hardware. Switch to the simulation selection. Select our schematic file. Add source, new source, also okay. New source here, we want to add a new test bench file. The test bench is read in Verilog module, so we choose the Verilog module and name it such as lab1 test bench. Okay, we don't have a test bench module here, so we choose the Verilog module here. Okay, and then click next. You will have a new Verilog module. I already have one. The test bench code actually is given here. You can copy from the lab manual, but you should complete the entire test bench so that our input bottom and top should have 4 different situations from 0, 0, 0, 1, 1, 0 to 1, 1. Okay. And let me make some clarification. In the lab manual, this sentence, the syntax here means we instantiate a new instance called UUT, lab1 test UUT, and we instantiate from the schematic file lab1 test. Here you see our schematic file is called lab1 test, and the instance come from our schematic file is called lab1 test UUT. Okay, and then the initial block 1 is our clock signal. Initial block 2 is the input signal switch. Okay. And we select our test bench and do the simulation. Okay. Select zoom to full viewer. You can see at the beginning our 2 input, top and bottom, are both in 0, 0. The AND gate A output should be 0, and the NOT of the A is B, should be 1. The C port's output C is our is an OR gate. So in this kind of situation, the output should be 1, and the NOR gate is the inverse of C, should be 1. In the next cycle, our input become, I think, 0, 0, 1, and then our AND gate A should still output and 0. The inverse A is the B, should be 1. Our OR gate switch to 1, and NOR gate switch to 0. Yeah. So your simulation should be exactly as this one. Hi everyone. Here we see our schematic design works on the FPGA board. The LED 0 is the AND gate output. LED 2 is the AND inverse, which is B. LED 4 is the OR gate. LED6 is the OR inverse. So far, our two input top and input bottom are both 0. So the AND gate should be 0. And inverse is 1. OR gate is 0. And OR inverse is 1. Okay. We switch the input. See? Here. Since we only switch the input bottom from 0 to 1, the two inputs are 0, 1, so the AND output is still 0, and inverse is still 1. OR gate becomes 1, and OR inverse becomes 0. We put the button. Right now, two inputs are both 1. So the AND gate becomes 1, AND inverse becomes 0. And OR gate is 1, and OR inverse is 0.